Hello students, so welcome to Dr. Haider Maths classes. So today we will discuss differential equation with variable separable, that is exercise 9.3. Exercise 9.3, differential equation with variable separable. Differential equation with variable separable. So as it is clear from the topic, variable separable means we have to separate the variable. means क्या करना है इसमें कि जो dy का टर्म है वो y वाले टर्म को dy की तरफ ले जाएंगे और x वाले टर्म को dx की तरफ रखेंगे और उसके बाद इंटीग्रेट कर देंगे, राइट? So the very first question is dy by dx is equals to 1 minus cos x upon 1 plus cos x. So सबसे पहले क्या करें, यहाँ पे आइडेंटिटी लगा लें. dy by dx 1 minus cos x means 2 sin square x by 2 and 1 plus cos x means 2 cos square x by 2 and this is cancelled. So dy by dx is equals to, this is equals to tan square x by 2 and now apply the variable separable. So dy is equals to tan square x by 2 into dx and now integrating on both the sides. So integration of dy is equals to integration of tan square x by 2 dx. So integration of dy is equals to y and tan square means there is no direct integration of tan square x by 2. So we will write secant square x by 2 minus 1 dx. So y is equals to the integration of sec square x by 2, that is tan x by 2 and the coefficient of x by 2 is 1 by 2. So it should be divided by 1 by 2 means 2 and minus x and with some constant c. So this is the final answer of question number 1. Okay. Now the next question is question number 2. And the second question is dy by dx is equals to root over 4 minus y square. So first apply the variable separable rule. So transfer this y terms to the dy. So this is dy upon root over 4 minus y square is equals to dx. So now variable is separated and now integrating on both the sides. So integration of dy upon 4 root over 4 minus y square is equals to integration of dx and this is the form of dx upon dy upon root over a square minus x square. So we can write dy upon 2 square minus y square is equals to integration of dx and this integration of this is sine inverse y by 2 and is equals to then dx, the integration of 1 dx, that is equals to x, plus c. So the y by 2, this can be written as y by 2 is equals to sine of x plus c. Transfer this inverse to the right hand side. So y is equals to twice of sine x plus c and this is the final answer of this question number 2. Okay. Now the third question is question number 3, that is dy upon dx plus y is equals to 1. So apply the variable separable. So this can be written as dy by dx is equals to 1 minus y. So dy upon 1 minus y is equals to dx. Okay. Now the variable is separated. So integrating on both the sides. Integration of dy upon 1 minus y is equals to integration of dx. Okay. And integration of this is equals to minus log of 1 minus y is equals to x. Here is log, so in place of this c we can write log c, and now transfer this log to the left hand side. So this is minus log c and minus log 1 minus y is equals to x. So now take minus log, take minus as a common, so this is log c plus log of 1 minus y is equals to x. So apply the property of log, so this will be log c of 1 minus y is equals to minus x, and transfer log to the right hand side, so there should be exponential. So c into 1 minus y is equals to e raised to minus x. So 1 minus y is equals to, that is e to the power minus x divided by c. Okay, so y is equals to, what will be the value of y? The value of y will be y is equals to 1 minus 1 by c e raised to minus x. Okay, and we can write this y is equals to 1 plus a e to the power minus x, where 1 by c minus 1 by c is equals to a. Okay, so or we can leave up to here also, doesn't matter. So anyhow, this is the solution of this question number 3. Okay, got it? Any doubt? Okay, now move to question number 4. Question number 4 I am going to solve. Okay, take the question number 4, and the fourth question is sec square x into tan y dx plus sec square y tan x dy is equals to 0. So this can be written as sec square x into tan y dx is equals to minus sec square y tan x dy, and now apply variable separable. So this is sec square x upon tan x is equals to minus sec square y upon tan y. Okay, this is dx and this is dy. So now the variable is separated, so integrating on both the sides, integration of sec square x upon tan x dx is equals to minus integration of sec square y upon tan y dy. And now apply here substitution method. So we put tan x is equals to t, so secant square x dx is equals to dt, and similarly put here tan y is equals to say p, So then secant square y dy is equals to dp. So this can be written as integration of dt by t, and this is minus integration of dp upon p. Okay, and the integration of this dt is equals to log modulus of t, and this is integration of minus log modulus of p. Okay, and now put the value of p, okay, plus c, but in terms of log, because here is log, both side is log, so we can take log of c. So this is equals to log of t plus p is equals to log c, and now put the value of t and p and remove the log from both the sides. So this will be equals to log of tan x into tan y is equals to log c, and remove log from both the sides. So this will be equals to tan x into tan y is equals to c, and this is the final answer of this question number 4. Okay. Now next question I am taking, that is question number 5. And the fifth question says, the question number 5. And the question number 5 is e to the power x plus e to the power minus x dy and minus e to the power x minus e to the power minus x dx is equals to 0. This is the question. So this is the simple one. Transfer this to the right hand side. So e to the power x plus e to the power minus x dy is equals to e to the power x minus e to the power minus x dx, and now apply the variable separable. So dy is equals to e to the power x minus e to the power minus x divided by e to the power plus x plus e to the power minus x dx. Okay, now variable is separated, so integration on both the sides. So integration of dy is equals to integration of e raised to x minus e raised to minus x upon e raised to x plus e raised to minus x dx, and put here substitution method. So put e to the power x plus e to the power minus x as t. So this will be e to the power x and minus e raised to minus x dx is equals to dt. So now this becomes the integration of dy, and this is dt upon t. Okay, and the integration of dy, that is equals to y, and this is the integration of log modulus of t plus c. Okay, and so this is y is equals to log, and put the value of t, that is e raised to minus x plus e raised to plus x. E raised to x and plus e raised to minus x and plus c, and this is the value of, this is the final answer of this question number 5. Okay, very simple question. And now next question, question number 6. And sixth question is again very simple question. Question number 6. And the sixth question is, dy by dx is equals to 1 plus x square into 1 plus y square. This is the question. Okay, so this can be written as dy upon 1 plus y square is equals to 1 plus x square dx. Variable is separated and अब क्या करें, वेरिएबल सेपरेट हो गया. नाउ इंटीग्रेशन ऑन बोथ द साइड्स. So integration of dy upon 1 plus y square is equals to integration of 1 plus x square dx, and integration of 1 plus y square, this will be equals to tan inverse y, and this is x plus integration of this is x cube by 3 and plus c, and this should be the answer of question number 6. Okay. Now the question number 7, and the seventh question says y log y dx minus x dy is equals to 0. So this is y log y dx is equals to x dy, and now rewrite in the form of apply the variable separable property. Okay. So this will be equals to dx upon x, and this will be dy upon, okay, so dx upon x is equals to dy upon y log y. So variable is separated. So now integration on both the sides, dx upon x is equals to integration of dy upon y log y. Okay, and here we will put log y as t. So put log y as t. So this is 1 upon y dy is equals to dt. So this can be written as dx upon x is equals to dy upon y, that is equals to dt. So dt upon t, and now integrate. So this is equals to log t, okay, log modulus of t is equals to log modulus of x, and in place of c take log c. Okay, so this is log t, and t is equals to, what is t? Log y. So log of log y is equals to, this is log of cx by applying the property of log, and now remove the log. So log y, this can be written as is equals to cx. So what will be the value of y? अगर हम log को इधर से इधर ले जाएंगे तो इधर क्या हो जाएगा? Exponential. So it will be e to the power cx, and this is the answer of question number 7. Okay. Now next question, that is question number 8. 8 I am going to take. Okay, question number 8. And 8th question is x raised to the power 5 dy upon dx is equals to minus y to the power 5. So this can be written as dy upon y to the power 5 is equals to minus dx upon x to the power 5. Now variable is separated. So integration on both the sides. So dy upon y raised to 5 is equals to integration of dx upon x to the power 5. So this will be of course minus y raised to minus 5 dy is equals to minus x raised to minus 5 dx, and integrate. So minus 5 plus 1, that is minus 4. So y minus 4 upon 4. Okay. And this will be equals to minus x raised to minus 4 upon minus 4. Okay. And this is plus c. Transfer this side. So this is y raised to minus 4 upon minus 4 plus x raised to minus 4 upon minus 4 is equals to c, and take the LCM of minus 4. So this will be y raised to minus 4 plus x raised to minus 4 is equals to c into minus 4, which is equals to the constant. So y minus 4 plus x raised to minus 4 is equals to, finally we can write c. Okay. Okay, now next question, question number 9 I will take. The 9th question. Question number 9th. Question number 9. 9 question is dy upon dx is equals to sine inverse x. So this is, apply the variable separable property. So dy is equals to sine inverse x and dx, and integration on both the sides. Dy, integration of dy is equals to integration of sine inverse x dx, and here we will apply the Eilert rule, that is integration by parts. Okay. So integration of dy is equals to y, and this can be written as sine inverse x into 1 dx, and apply the integration Eilert rule. So this will be the first function and second function. So y is equals to sine inverse x into integration of 1 dx minus integration of d by dx of sine inverse x into integration of 1 dx and whole dx. Okay, this is integration by parts. So sine inverse x and integration of 1, that is equals to x. So we can write x sine inverse x and minus integration of derivative of sine inverse x, that is 1 upon 1 minus root over x square, and 1 dx, that is equals to x, and finally dx. Okay, and now put 1 minus x square as t, so we will get minus 2x dx is equals to dt. So x dx is equals to minus 1 by 2 dt. Okay, so this y becomes x sine inverse x, and this minus minus plus 1 by 2. Okay, and dt upon root over of t. So this is x sine inverse x plus 1 by 2. So this is t integration of t raised to minus 1 by 2 dt. So x sine inverse x plus 1 by 2, and it will be minus 2 plus 1 minus t raised to minus 2 plus 1 upon minus 1 by 2 plus 1 and plus c. So the final result where I will write, so this is equals to x sine inverse x, and this 1 minus 1 by 2, 1 by 2 means 2 by 2, so it will be cancelled out. So this is t to the power 1 by 2, so we can write root over t and plus c, and finally put the value of t. So final answer should be x sine inverse x, and the value of t is root over 1 minus x square and plus c, right? This 2 and this 2 will cancel because 1 minus 2, that is 1 by 2, so it will be 2 by 1. So 2 and 2 cancel, so I have written directly root t. Okay. And now come to the next question, that is question number 10. That is question number 10. And the 10th question is question number 10. This is e to the power x tan y dx plus 1 minus e to the power x into sec square y dy is equals to 0. So we can write e to the power x tan y dx is equals to minus 1 minus e raised to minus x into sec square y dy. Okay. And now apply variable separable rule. So variable separable rule means it should be equal to minus of e to the power x upon 1 minus e to the power x dx is equals to sec square y upon tan y and dy. So variable is separated. So now apply integration on integrating both the sides. So integration of sec square y upon tan y dy is equals to integration of e raised to power x upon 1 minus e raised to the power x dx. Here put tan y is equals to t. So you will get sec square y dy. This is dy. This is dy. So this is dy. Okay. So put tan y as t. So this is sec square y dy is equals to dt, and here put 1 minus e to the power x as say p. So this is 0, and minus e raised to the power x dx is equals to dp. Okay. So this will be equals to dt by t, and minus this will be equals to minus plus, and e to the power x dx, that is dp upon p. Okay. And now integrating on both the sides, so it will be log modulus of t is equals to log modulus of p and plus take log c. So log, and the t value of t is, that is tan y is equals to log pc. The value of p is 1 minus e raised to the power x and into c. So remove log from both the sides. So finally it is tan y is equals to 1 minus e to the power x into c, and this is the final answer of this question number 10. Okay. Now the next question, question number 11th onwards, that is the case of particular solution. Particular solution means we have to put the value of x and y, whatever it is given, and then we will find the final result. But anyhow the process remain same. कि first सबसे पहले हमने क्या करना है, एक क्वेश्चन को देखना है, और क्वेश्चन को देखने के बाद वेरिएबल सेपरेबल प्रॉपर्टी लगाएंगे, और वेरिएबल सेपरेबल प्रॉपर्टी लगाने के बाद दोनों तरफ इंटीग्रेशन करेंगे. इंटीग्रेशन करने के बाद ओके, आफ्टर इंटीग्रेशन सी के टर्म्स में हमारा रिजल्ट आएगा, फिर वहाँ पे एक्स और वाई की वैल्यू निकाल लिया जाएगा, और एक्स और वाई की वैल्यू निकालने के बाद उसको जो आपका फाइनल इंटीग्रेशन आया है वहाँ पे उसको रख दिया जाएगा। ओके, और तब जा करके हमारा सॉल्यूशन कंप्लीट होगा। ओके, लेट मी इरेज दिस वन ऑल्सो, देन वी विल स्टार्ट क्वेश्चन नंबर 11 onwards. Okay, now question number 11, and the question number 11 is x cube plus x square, x cube plus x square plus 1 plus x plus 1 dy upon dx is equals to 2x square plus x, where such that y is equals to 1 and x is equals to 0. This is the question. इसमें भी वही करना है आपको, वेरिएबल सेपरेबल अप्लाई कर दें, तो this can be written as dy is equals to 2x square plus x upon x cube plus x square plus x plus 1 into dx. Okay, and now variable is separated, so integration on both the sides. So integration of dy is equals to integration of 2x square plus x upon x cube plus x square plus x plus 1 dx. Okay, so here x cube, so this can be written as 2x square plus x upon x square is coming common, so x plus 1, and 1 is coming common, x plus 1 and dx. So this is 2x square plus x upon x square plus 1 into x plus 1 dx. Okay, this is the, now so integration of dy, this is equals to y. So y is equals to integration of 2x square plus x upon x square plus 1 into x plus 1 dx. Okay, and put it result number 1. Now integrate this one, this right hand side. Okay, so we will apply the integration of partial fraction. Okay, so 2x square plus x upon x square plus 1 into x plus 1 can be written as a upon x plus 1, and here is quadratic, so it should be bx plus c upon x square plus 1. Okay, LCM will remain same, so this will be 2x square plus x is equals to a into x square plus 1 and plus x plus 1 into bx plus c. And now find the value of a and b, c and put it here and integrate. Okay, so one factor is linear, so we can put x plus 1 as 0, so it means x is equals to minus 1. So this is minus 1 means 2, and minus 1 and minus 1 is square plus 1, so this is equals to 2, and now this will be 0. Okay, so this implies that 1 is equals to 2a, therefore the value of a we got 1 by 2. We got the value of a, that is a is 1 by 2, and now we have to find the value of b and c. So equating coefficient of x square and for the c constant term on both sides. okay, on both sides. So here the coefficient of x square is 2 and here the coefficient of x square is a, and x into bx, the coefficient of x square is b, and the value of a we already calculated. So this is 2 minus 1 by 2 is equals to b. So therefore the value of b is equals to 3 by 2. We got the value of b as 3 by 2. And equate the constant term on the both hand side. So on the left hand side there is no constant term, so it is 0. And here the constant term is a plus a into 1, that is a. And here the constant term 1 into c, that is c. And the value of a we already calculated. So value of c is equals to minus 1 by 2. So we got the value of a, b, c. So integration of 2x square plus x upon x square plus 1 into x plus 1 is equals to the value of a. The value of a is 1 by 2 integration of dx upon x plus 1, and the value of b is 3 by 2 x, and the value of c is minus 1 by 2 upon x square plus 1, okay, and dx. So this is equals to 1 by 2, and that is log of x plus 1, okay. So 2 is the LCM, so 3x minus 1. So this is 1 by 2 integration of 3x minus 1 upon x square plus 1 dx, okay. Now apply the separation property. So this is 1 by 2 log x plus 1 and plus 1 by 2 integration of 3x upon x square plus 1 dx, and minus 1 by 2 integration of 1 upon x square plus 1 dx by applying the separation rule. And now substitution method. So put x square plus 1 as t, you will get 2x dx dt. So x dx is equals to dt by 2. So 1 by 2 log modulus of x plus 1, okay, and then it will be t by 2 means it should be 3 by 4, okay, and log modulus of x square plus 1, and this is minus 1 by 2 tan inverse x and plus c, okay, plus c. So put the value of y is 1 and x is 0 when y is equals to 1 and x is equals to 0. So this is equals to, this is y, okay, this is y, this is equals to y. So we have to find the value of c. So x1 is equals to 1 by 2 and x is 0, so it is log 1 and plus 3 by 4 log 2, sorry, it will be log 1 because x is 0. So log of 1 and minus this is 0, tan inverse 0 means 0, and plus c, and log 1 is 0, so the value of c is equals to, therefore the value of c is equals to 1. We got the value of c, okay, and now put the value of c here and get the final result, okay. So therefore from second, y is equals to uh, we can take 1 by 4 as common. So this is 1 by 4 and 2 log of x plus 1 plus 3 log of x square plus 1 and minus 1 by 2 tan inverse x and plus the value of c is 1. So one more step. So final answer should be y is equals to, okay, y is equals to 1 by 4, and this is log of x plus 1 whole square, and this is, so it should be log of x plus 1 whole square into x square plus 1 whole to the power 3, okay, and minus 1 by 2 tan inverse x plus 1, and this is the final answer of this question number 11, right? Okay, so slowly we are getting the little bit lengthy solution, but anyhow we have to simplify. Okay, now next question is question number 12. Okay, are you getting the solution or any doubt? Let me clean this board because solutions are coming lengthy and lengthy. Okay, now the next question is question number 12. Question number 12. Question number 12. And 12th question is x into x square minus 1 dy by dx is equals to 1 when y is equals to 0 and x is equals to 2. This is the question. So apply the variable separable property. So dy upon dx is equals to 1 upon x into x square minus 1. So dy is equals to dx upon x into x square minus 1. So variable is separated. So now integrating on both the sides, dy is equals to integration of dx upon x into x square minus 1. Okay. So this can be written as further dx upon x into x minus 1 into x plus 1. Okay. And integration of dy, that is equals to y is equals to integration of dx upon x into x minus 1 into x plus 1, and again apply the partial fraction. Okay, so 1 upon x into x minus 1 into x plus 1 is equals to a by x plus b upon x minus 1 plus c upon x plus 1, right? So LCM will remain same. So 1 is equals to a into, this x will cancel. So this is x minus 1 x plus 1 x square minus 1, and now x minus 1 will cancel out. So b into x plus 1, and then x plus 1 will cancel out. So c into x minus 1. Okay, and now all the factors are linear. So we will put, first put x is equals to 0. So 1 is equals to a into minus 1, and now this will be 0 and this will be 0. So we got the value of a is minus 1. And now put second factor, x minus 1 is equals to 0. So this implies that the value of x is 1. So this is 1 and now this will be 0 and plus b into 1 plus 2, that is equals to 2. Okay, and now this will be 0. So we got the value of b. The value of b is equals to 1 upon 2. Okay. And now put third factor, that is x plus 1 is equals to 0. So x is equals to minus 1. So this will be 1 is equals to the square of minus 1, 1 minus 1, this is 0. And this will be 0. And this will be plus c into minus 1 and minus 2. So this is plus 2. So therefore the value of c is also coming 1 by 2. Okay. So integration of, so put it number 1, and integration of dx upon x minus x into x minus 1 into x plus 1 is equals to the value of a is minus 1. Okay, the value of a is minus 1. So this is integration of minus dx by x, and the value of b 1 by 2, and integration of dx upon x minus 1, and the value of c is also 1 by 2. So integration of dx upon x plus 1. So this is equals to minus log modulus of x. Okay, minus log x, and this will be 1 by 2 log modulus of x minus 1 and 1 by 2 log modulus of x plus 1 and plus c, right? So from first y is equals to minus log modulus of x plus 1 by 2 log modulus of x minus 1 plus 1 by 2 log modulus of x plus 1 and plus c. And now put when y is equals to 0 and x is equals to 2. This is the case of particular solution, and find the value of c, and after getting the value of c, put it in the second result. That will be our final answer. So y is 0 and x is 2. So this is minus log 2 minus log 2. Okay, minus log 2, and this will be, can be written as 1 by 2 and log of x square minus 1. Okay, so log of x square minus 1 and plus c. So do one thing, simplify here, and then we will put, okay, then we will put the value of y and x, then it will be easy. So from first, y is equals to minus log x and plus 1 by 2 log of x minus 1 x plus 1, this is x square minus 1 and plus c. Okay, and what we have to do now, this is 1 by 2. So here is log 2 something. What happened? Log x. So this can write minus 1 by 2 into 2 log x and plus 1 by 2 log of x square minus 1 plus c. Okay, so Now take 1 by 2 as common. So 1 by 2 log of x square minus 1 and divided by, this is log of x square means x square and plus c. Okay. So put it result number 2, and now when y is equals to 0 and the value of x is equals to 2, so 0 is equals to 1 by 2 and log of 4 minus 1, that is 3, and 2 square means 4. Okay, and plus c. So this is equals to, what about the value of c? The value of c is coming minus, so therefore the value of c is equals to minus 1 by 2 log of 3 by 4. Okay, this is the value of c. So from second result, y is equals to 1 by 2 log of x square minus 1 upon x square, and put the value of c. C is minus 1 by 2 log of 3 by 4, and this is the final answer of question number 12. Okay. Now next question, we are coming to next question, that is question number 13. Okay, 13th question. I am coming. Let me erase. Question number 13. And the 13th question is cos dy by dx is equals to a. So we can write, and when y is equals to 1, solution is given, y is 1 and x is 0. So we can write dy by dx is equals to cos inverse a. Okay, and now apply the variable separable. So dy is equals to cos inverse a is constant, and 1 dx into 1 dx into dx, cos inverse a dx. Okay, so integration of dy is equals to cos inverse a is constant, so integration of 1 dx, variable separable property applied, and the integration of dy is y, and the integration of 1 is x, so we can write x cos inverse a and plus c. Okay, and what is given, y is 1 and x is 0. So when y is equals to 1 and x is equals to 0, so 1 is equals to the whole result is 0 plus c. So therefore the value of c is coming 1. So finally y is equals to x cos inverse a and plus 1, and this is the final answer we can write here. Or we may proceed, y minus 1 is equals to x cos inverse a, or we can write y minus 1 upon x is equals to cos inverse a. So finally this can be written as cos inverse, transfer to the right and left hand side, so cos of y minus 1 upon x is equals to a. Okay, this is the final result. Now the next question is question number 14, and the 14th question is dy by dx is equals to y tan x when y is equals to 1 and x is equals to 0. This is the question number 14. Okay. So apply the variable separable. So it will be dy upon y is equals to tan x dx, variable separable applied. And now integrating on both the sides. So integration of dy upon y is equals to integration of tan x dx. Okay. And this is the integration of 1 upon y, that is log y is equals to, this will be log of secant x. Okay. In terms of sec अगर लिखते हैं तो sec x, अगर cos लिखेंगे तो minus log of cos x. Okay. And plus c means we can take log c. Okay. So this is equals to log y is equals to log of sec x into c. Okay. So y is equals to sec x into c. And now put the value of y is 1 and x is equals to 0. So when y is 1 and x is equals to 0, so 1 is equals to sec 0, 0. So sec 0, that is 1, sorry, sec 0, 1. So 1 into c. So therefore the value of c is equals to 1. So from the first, y is equals to secant x, and this is the final answer of question number 14. Okay. Now the next question is, find the equation of the curve passing through the point 0, 0. Passing through the point 0, 0 means the value of x is 0 and y is 0, whose differential equation is given. Okay. So question number 15. So for the question number 15, let me erase. Then we will start question number 15. Question number 15. So the differential equation is given. Y dash means dy by dx is equals to e to the power x and sine x, and which passing through the origin. Passing through the origin means x is equals to 0 and y is equals to 0. Okay. So again the process remain same. So dy dash means dy by dx is equals to e to the power x sine x. So apply the variable separable. Dy is equals to e to the power x sine x dx. Now integrating on both the sides. So integration of dy, integration of e to the power x sine x dx. And here we will apply integration by parts. Okay, by applying the Eilert rule. So as per the Eilert rule, this should be the first function and this should be the second function. So dy means y is equals to, this is equals to, this can be written as sine x into integration of e to the power x dx and minus integration of d by dx of sine x into integration of e to the power x dx and again dx. So this is equals to e to the power x sine x and d by d of sine, that is cos x, and into e to the power x dx. Okay. So again applying the integration by parts. This is first and this is second. So e to the power x sine x minus, and this is can be written as cos x into integration of e to the power x dx and minus integration of d by dx of cos x integration of e to the power x dx and dx. So this is e to the power x sine x minus e to the power x cos x. Okay. And the derivative of cos is minus sine. So this will be equal to minus minus plus integration of sine x into e to the power x dx, and this is equals to this I1, this value again. Okay, so this is equals to, or do one thing, we can write as I, then it will be more clear. So therefore, because okay, so we can write y is equals to integration of e to the power x sine x dx, and let put y is equals to I1. Okay, y is equals to I1. So we will write here, this is I1. I1 is equals to this much. So open this. So e to the power x sine x minus e to the power x cos x, and minus integration of sine x into e to the power x dx, which is equals to I1. So I1 is equals to e to the power x sine x minus e to the power x cos x, and minus I1. So this is 2I1 is equals to e to the power x, we can take common. So sine x minus cos x. So the value of I1 is equals to e to the power x by 2 into sine x minus cos x. So now from first result, okay, from first result, y is equals to, and then plus c also, of course. The value of I1 is equals to e to the power x by 2 into sine x minus cos x and plus c. Okay, and now as per the question, okay, it is passing through the origin, so the value of x is 0 and y is 0. So as per the question, it is passing through the origin. So put x is equals to 0 and y is equals to 0 to get the value of c. So 0 is equals to x e to the power 0, that is 1, 1 by 2, and sine 0, 0, and cos 0 minus 1 plus c. So we will get the value of c. The value of c is equals to 1 by 2. Okay. So from second result, from result number second, this y is equals to e to the power x by 2 into sine x minus cos x, and the value of c, that is 1 by 2. Okay, so we can write this 2 as the LCM, or we can write, leave it here. So anyhow, so this 2 will be the LCM, so it will be 2y, and transfer 1 this side, then e to the power x into sine x minus cos x, and this is the final result of question number 15. Okay, now the next question is the word problem. The question number 16. For the differential equation x dy by dx is equals to x plus 2 into y plus 2, and find the solution of the curve passing through the point 1 and minus 1. The same type of question. In the previous question, it was passing through the origin, and now in this question, it is passing through the minus 1 or 1 or 1 or minus 1. Okay. So let me erase this. Question number 16. This is xy dy by dx is equals to x plus 2 into y plus 2, and it is passing through x is 1 and y is minus 1. From this point it is passing. So first of all we will write this can be written as y upon y plus 2 dy is equals to x plus 2 upon x dx, right? So here is y plus 2, so we can write plus 2 and minus 2 upon y plus 2 dy, and similarly here apply the separation property. Okay, so x plus 2 upon x dx and apply the separation property. So this is 1 minus 2 upon y plus 2, okay, dy is equals to 1 plus 2 by x dx. Okay, and now start integration. So integration of 1 minus 2 upon y plus 2 dy is equals to integration of 1 plus 2 by x dx. So this integration of this is y minus 2 log modulus of y plus 2, okay, is equals to x, and this is equals to 2 log modulus of x and plus c. Okay, now it is given that x is equals to 1 and y is equals to minus 1 to find the value of c. So this is minus 1 and minus 2 log minus 1 plus 2 minus 1 plus 2, that is log 1, and x is 1 and 2 log x means 2 log 1 and plus c, and log 1 is 0, so it is minus 1, and 1 plus c again log 1 is 0, so therefore the value of c we got minus 2. So from the first result, the final equation y minus 2 log y plus 2 is equals to x plus 2 log x and minus 2, or we can write like this, or we may leave it up to here, or we can write one more step. So this is y minus x plus 2, transfer this to the right hand side, so this will be equal to log of x square and this side plus, so this will be in the form of multiplication into y plus 2 whole square. Okay, and this is the final result of this question number 16. Okay, now the next question is question number 17, and the 17th question is, a statement is given, you find the equation of the curve passing through the point 0 and minus 2, means the value of x is 0 and y is minus 2 passing through this point, and given that any point xy on the curve and the product of the slope of the tangent, so slope of the tangent means dy by dx, and y coordinate of the point is equals to x coordinate of the point. Okay, so according to condition or according to question, is product of slope of tangent dy by dx into y coordinate is equal to x coordinate, right? So this is the slope of tangent. Okay, now y dy is equals to x dx, and then integration of y dy is equals to integration of x dx. So integration of y means y square by 2, and this is x square by 2 plus c. Okay, and this now curve is passing through, x is equals to 0 and y is equals to minus 2. So minus 2 square means 4 by 2 is equals to 0 by 2 plus c. So this is 2. So the value of C should be equal to 2. Okay. The value of C is 2. So now from this result, first result, so y square by 2 is equals to x square by 2, and the value of C is 2, or we can take 2 is the LCM. So y square by 2 is equals to, so x square plus 4. So this should be cancelled out. So y square is equals to x square plus 4. Okay. So this is the final result of this question number 16. Okay, 17, sorry. Now another question is question number 18. At any point xy on the curve, the slope of the tangent means dy by dx, is twice the slope of the line segment joining of the point to the contact to -4 and -3, and find the equation of the curve given that passes through -2, -1, right? So slope of line joining of the 2 points, in the 11th class you have read that if for slope of line joining the 2 points is equals to y2 minus y1 upon x2 minus x1. This formula we will apply in this question. Okay. So question number 18. So let me erase this question number 16 and 17. Then we will proceed. Okay. Question number 18. So slope of the tangent, this is equals to dy by dx, and slope of line joining between the 2 points x, y and -4 and -3. So this is equals to y plus 3 upon x plus 4, right? And according to question, the question says the slope of the tangent means dy by dx is equals to twice of the slope of line joining. Okay, so twice of this. And now apply the variable separable property. So this can be written as dy upon y plus 3 is equals to twice of x plus 4 into dx. Okay. So variable is separated. Now integration on both the sides. So dy upon y plus 3 is equals to twice of dx upon x plus 4. And now integrate. So this is equals to log of y plus 3, and this is twice of log of x plus 4. Okay, and plus log c we can write. So log modulus of y plus 3 is equals to this, we can write log of x plus 4 whole square into c. No, apply this property here and then apply the multiplication rule, or we can write, otherwise it will be problem like this. So and plus log c, then transfer this side. So log of y plus 3, and now it will be minus this side. So x plus 4 whole square is equals to log of c. So in this way we will get the direct value of c. So y plus 3 upon x plus 4 whole square is equals to c, right? It number 1. And now as per the question, this is passing through, at which point it is passing through? It is passing through the point 0 and -2. So x is equals to 0 and y is equals to -2. So this will be equal to uh, this will be equal to the value of y is -2. So -2 plus 3 upon x is 0, 4 square. So 4 square means 16. That is equals to c. So the value of c, 4 square, the value of x is, it is passing through 0 and -2. X is 0. X is 0. Okay, it is passing through 0 and -2. So x is 0 and y is -2. So -2 plus 1 upon 0 plus 4. Y is, question number 18 I am taking, sorry, it is passing through -2 and 1. I have seen push the passing point if this is 0 -2. So here x is -2 and y is 1. X is -2 and y is 1. It is passing through this point -2 and 1. Okay, so this is 1 plus 3 upon -2 plus 4 whole square is equals to c. So this is 4 upon 2 square, 4, that is c. So the value of c is equals to 1. So from first, okay, y plus 3 upon x plus 4 whole square is equals to 1. So y plus 3 is equals to x plus 4 whole square. We can leave up to here, or y is equals to x plus 4 ka whole square and -3. This should be the answer of question number 18. Okay. Okay, now the next question is question number 19. The volume of a spherical balloon being inflated changes at constant rate. Initially, its radius is 3 units, and after 3 seconds, it is 6 units. Then find the radius of balloon after t seconds. Okay. The volume of a spherical balloon is inflated. Okay, let me erase. Then I will solve the next question number 19. Question number 19. Let the rate of change of volume, the rate of change of volume of the balloon be, suppose k, where k is any constant. So rate of change of volume means dv by dt is equals to dv by dt is equals to k, where k is any constant. This is given. Now volume of a sphere, because balloon is a sphere, so volume of balloon is 4 by 3 pi r cube. So v is equals to 4 by 3 pi r cube. and since it is changing with respect to time, so dv by dt, so dv by dt is equals to 4 by 3 pi into 3 r square dr by dt. So this 3 and 3 cancel out, and the value of dv by dt, that is k, so k is equals to 4 pi r square dr by dt. Okay, and so this is k dt is equals to 4 pi r square dr. So variable is separated, and now integrating on both the sides. So k dt is equals to integration of 4 pi r square dr. So k is constant. So this is kt, kt, and plus take some constant c, and 4 pi is constant, and integration of r square will be r cube by 3. Okay, r cube by 3. So this is equals to 3 times kt plus c is equals to 4 pi r cube. So put the result number 1. And as per the question, initially time is equals to 0 and radius is equals to 3. Okay, radius is 3. Then this is equals to, this is 0, t is 0. So this is 3c is equals to 4 pi into 3 cube means 27, and 3 nines are 27. So value of c is equals to 9 for the 36 pi. Okay, and after t seconds, this is according to question. And another question says at t is equals to 3, at t is equals to 3, at t is equals to 3, and radius becomes 6, r is equals to 6, then this will be equal to 4 pi 6 to the power 3 is equals to 3 into 3k plus c. So 6 to the power 3, 36, 216. So 4 pi into 216 is equals to 3 into 3k plus c. So we can cancel out 72, right? This is 72. So 4 2s are 8, 288 pi is equals to 3k plus c. And the value of c is 36 pi. So 288 pi and minus 36 pi is equals to 3k. So 8 minus 6, 2, and 8 minus 3, 5, 252 pi is equals to 3k. So this will be cancel out, 3 8s are 24, 3 4s are 12. So 84 pi is equals to k, right? We got this value. So putting this value, putting value of k and c in relation number 1. So the first relation is 4 pi r cube. So 4 pi r cube is equals to 3 into k, 84 pi t, 84 pi t, and plus 36 pi. So this is equals to 4 pi r cube is equals to 3, and take 4 pi as common. Okay, so this is 21t and plus 9. So this 4 and 4 cancel, and this pi and pi also cancel from both the sides. So the value of r cube is equals to 3 to 63 t plus 27. So this is r is equals to 63t plus 27 whole to the power 1 by 3. So this is the final answer. Okay, so radius becomes, after t seconds, it becomes the answer of this question. Okay, this is question number 19. Word problem. These questions are not so important, 19, 20, 21, but the question number 16, 17, 18 are, these are the important question. But anyhow, we will discuss each and every question. Okay, now the next question, question number 20. And question number 20, that is, in a bank, principal increases continuously at the rate of r% per year. Find the value of r if rupees 100 is double itself in 10 years. And one condition is given, the value of log 2, this is given 0.6931, that we will use. Okay, so next question is question number 20. Let me erase. Question number 20. So initially, let P and T be the principal, and time. Okay, so principal increases 5% per annum. Since principal is increasing at 5% per annum, so P means principal, so this is dP by dt is equals to 5% means 5 by 100 into P, 5 by 100 of P, 5% per annum. So this is 5 by 100 of P, 5 by 100 of P. So now apply the variable separable property. So this is dP upon P is equals to 500 into dt, 5 by 100 into dt. So integration on both the sides. So integration of dP upon P, this we can cancel out. So 1 by 20 and integration of this is dt. And so this is equals to log of P is equals to T by 20 and plus C. Okay, so the value of P is equals to exponential, so e to the power T by 20 plus C, and put it result number 1. And according to question, when T is equals to 0 and principal is equals to, how much it is given, rupees 100 double. 1000. So this is equals to 1000 is equals to 0 by 20 means 0, so it will be the value of e to the power c. Put it result number 2, and at p is equals to 10, so this is equals to p is equals to e to the power 1 by 2. When t is equals to 10, then p is equals to e to the power 1 by 2 plus c. Okay, so we can write p is equals to e to the power 1 by 2 into e to the power c, and e to the power c is into 1000, the value of e to the power c. So p is equals to e to the power 1 by 2 into 1000 from result number 2. Okay, and so this is principal is equals to e to the power 0.5 into 1000, and e to the power 0.5 is given 1.648 into 1000. Since e to the power 0.5 is given 1.648, so it will be 1648. This is the value of p, right? This is the value of p. Okay, now the next question is, so this is all about your exercise variable separable, and I think you like this solution, and if you like this solution, please press the like button and don't forget to share to your friends. Okay, अपने दोस्तों को अब इस चैनल को ज्वाइन करने के लिए कहिए, ताकि आपको सॉल्यूशन सही टाइम पर मिल सके और आने वाले एग्जामिनेशन में आपको हेल्प मिल सके. थैंक यू वेरी मच.